Once we are done with the next topic, then I'll come back to, or I'll be able to come back and discuss on the database design and also something on the data flow diagram, how we can be able to construct them. We are also very much aware that next week will be the last day for the lectures, so that the other week we can be able to start our exams. My prayers are that we can be able to finish the syllabus by then next week. So allow me to proceed with the business of the day. Sorry. So today I want to start a new topic, but I know there's something that is pending, and I'll come back to that particular section by next week. So the next topic, number 5, it's about prototyping and implementation. We have been able to see how you get the requirements from the user. We have been able to see how do you do the analysis of the current system using some techniques like the flowcharts, things to deal with them, things to deal with the data flow diagrams, among other techniques. And we have also been able to see how you can be able to design your system. Now, at this point, we will look at how we now proceed on. Once you have the requirements, once you have been able to do the design and the analysis of the system, we now proceed and look at how we can be able to make a small working or a working model of the final system and how we can be able to implement that system. So by prototyping, and this is something you might be very much conversant with, a prototype simply means a small working version of the final system. And when we say a small working or a working model of the proposed system or the system we are predicting to come up for the user, it means that this system will not have full functionality. And it's just like a skeleton, a working model. How will your final system look like? It might not be able to add, or it might not have the exact logic of the original software or of the final system you are proposing, but it's supposed to be a skeleton or some bony representation of how your system will look like once you have been able to deliver the system at the end of the day to the customers. And most times the developers will use prototyping or a prototype for them to be able to capture requirements from the user at early stage of development. So the main aim when you are doing prototyping, you want to be able to give the user a small working or a working model of the system. Then they can see how it's like, how will the final system likely look like. Once they have that look and feel, we can get that feedback from the customer. Then with the feedback, you can be able to incorporate this feedback back into the design before you can start creating the final system. So prototyping is simply a way you can be able to get that kind of early requirements from the user, because when you start creating a system, most times you are not very sure what kind of system you want to develop for the user, what kind of system the user wants to be developed by the developer. And we can just do a skeleton, then use the skeleton to get the early requirements, get the feedback, feedback the feedback to the design again, then keep on fine-tuning that particular prototype. And in some cases, the prototype or that working model can become the final system. So let's briefly look at why you do require prototyping, or why do you have to have a working model of how your final system will look like. A prototype will allow the user, that is the customer or the person whom we are creating the system for, evaluate the developer proposal before they can even be able to implement those proposals. In system development, you want to be able to mitigate the risk of the system failing. You don't want the system to be rejected by the user at the end of the day. So as much as possible, as the person developing the system, you want to be able to bring the user on board so that every step you are going to be going through, you are going to be moving with the user. And through that, we can be able to evaluate the proposal and even try out some things before we can even be able to implement those items. Once you implement some of these features, it becomes quite expensive. It's like you're investing a lot of resources for you to be able to make the final system. You don't want to invest so much in the coding, then you find that the customers will now reject your system. That's why we have to do a prototype. Number two, prototyping will also enable the user or help the person creating the system to be able to understand what is needed to be captured. And that's what we are calling the requirements. Once you have done a proper prototype or a working model of the system, then you can be able to know what are going to be the specific requirements. You can even be able to know what user shall be using the system and for what purpose. You can also be able to capture things, for example, on there's a feature you are not considered when you are designing the system. That can come out very clearly once you prototype the system, give the user the prototype to use, then you get the feedback from the user. And we can now be able to look at how can you be able to do or what are the stepwise or what is going to be the structured methodology for you to use when you are doing prototyping. And the first thing is for you to identify the requirements that you want to capture for that particular system. For us to capture the requirements, we can use some fact-finding techniques. For example, you can use questionnaires, you can use interviews, you can, for example, use sampling, observations, and many other types of fact-finding techniques. And that one becomes step number one. There's no way you can start creating a system if you don't understand the requirements that need to be captured in your system. So this stage is about understanding the very basic product requirements, especially in terms of the user interface. How do the user want the user interface to look like? This is very key when you are creating your system. So there's no way you can start creating a system before you understand how the interface will look like. What controls will you be using on the interface so that you can be able to make your interface more appealing? Issues to deal with complex details of internal design. Things to deal with external aspects like performance of the system. Security will not be done when you are doing the requirement identification. So the most complex things like how will the system be operating? What will be some external aspects? For example, you want to make the system to be 24/7 available. You want to make the system secure. Those things will not be dealt at this stage. So this is just a stage purely for us to be able to know what kind of requirements do you want to capture in the system without going into detail about the technical issues. Then once you have been able to identify the basic requirements, what I want to capture on the system, then you can come up with an initial prototype. And this prototype is simply a very basic or will have very basic requirements that will be able to showcase or that will be able to inform the user or that will be able to convey to the user the requirements you have captured and how the user interface will look like. So look at it from this angle that number one, you have to understand the requirements first. Once you understand the requirements, you have to communicate these requirements back to the user or the client. And for you to be able to communicate the requirements back to the client or the person who shall be using the system, then you have to do an initial prototype. That initial prototype, number one, can become the final system once the user has satisfied that that is the system, or that's how they want the system to look like. Or you can also decide that this system, we are going to discard it. And once we discard the prototype, we shall now be able to create a system based on the prototype that the user agreed upon. I think in the next few slides, we shall be looking at the different types of prototype and when each can be used in system development. So while the workaround, I used to give the same look and feel to the customer in the prototype or in the prototype development. So in short, we are saying you collect the requirements, but from the requirements, you now identify how will your final prototype, or how will a prototype that will be able to meet the user requirements look like. Because you have to give some kind of a look and feel to the customer that I collected these requirements, and this how this system will be representing these particular requirements. So then we look at step number three, sorry for that. After you have done your prototype, that's not the end. You need to keep on reviewing, you need to keep on revising and enhancing the prototype. And this is purely something on collecting the feedback from the user. Yes, the user has been able to use the prototype. What is their feedback? Are they okay with how the prototype looks like? What are the comments coming from the user? Are they satisfied with the system that we want to make for them? So if this the feedback coming from the user could either be positive or negative. The user can tell you improve on aspect number A, or the user can say we are very okay with feature number B. It's upon you as the person creating the system to get that feedback from the user and try to see this feedback I've gotten from the user, how do I feed it again back to my system? Then keep on enhancing the prototype until that time the prototype will get to a level where the user are more satisfied. So there are some kind of negotiations that can happen between the customer and the person creating the system. For example, something to deal with the time and budget that need to be agreed between the developer and the customer creating the system. Things to deal with technical feasibility study of how the system shall be implemented, because you need to be able to agree that the system or the prototype we have been able to propose to you, it's either technically viable or not viable. If let's say today you are proposing that you want to come up with a robot for a certain organization, as the developer, you need to be able to do proper feasibility study so that you can be able to ascertain that in the market, this robot can be able to operate technically. This robot, we do have the enough expertise that can be able to construct the robot. If at all that knowledge is not there, then you look at, can we be able to outsource some kind of technical expertise? If let's say we do outsource the expertise, how expensive will it be for us to implement that system? That is something that will be done in step number 3. So you need to revise and keep on enhancing the prototype. And this one is purely based on the feedback that comes from the user. Because you will not assume that once you have been able to release the product in the market, that this user or the people using the system will, or the people who are supposed to be using the system will just buy your idea. that might not be the case. You'll always keep on getting feedback, and it's that feedback as a designer that is very critical. That feedback will determine whether the user will be able to accept your system or shall be able to reject your system. We are not trying to create a system whereby the user will be able to reject that system. So get the feedback and enhance the prototype, step number 3. Then this feedback, as we have said, you incorporate the feedback back into the design and keep on repeating the same cycle of getting the feedback. Feed it again back to the system until the customer expectations have been met. If the customer expectations have not been met, then there's no way you can now start creating the system. You can only start creating the actual system once the customer expectation, the user expectation have been met from their side of view. And also remember, when you are creating a system, you are not creating a personal system. This is not your system. This system is meant for a certain colleague, or it's meant for a certain clique of people. Sometimes as designers, we always create system with the illusion that I am the one who shall be using the system, but that's not the case. You cannot be the developer and the user using the system. So make sure that you try to work with the expectations of the user until they are met. So we look at something we call prototype fidelity. And when we speak about fidelity of a prototype, it means how close is the prototype close to the final system. As I've said from the word go, a prototype is simply a working model of the final system. And we can be able to say that a certain prototype is very close to the final product, or it's not very close to the final product. And that fidelity, it's what defines a prototype fidelity. If you find that the prototype, it's almost like the final product we are coming up with, then we can be able to say that that is an high fidelity prototype, because the prototype and the final system are almost the same. If you find that the prototype and the final system are far much alike, that means they are not very close. I'll just give you an example. You can be able to do a prototype using some paper sketch. Definitely, that paper sketch will not be very close to the prototype in case, let's say, you are implementing a system. And we always say that a paper prototype will be a low fidelity prototype. But if, let's say, I do a prototype using a certain software like HTML and CSS, and I want to show the user that this is how the final system will look like, but you find that the material I've been able to use, it's almost like the same material I shall be using to implement the final system, or the system we are proposing, then that one becomes a high fidelity prototype. So we look at, still we can say that prototypes can either be horizontal or vertical dimensions. And I want to zoom in into these two aspects of prototype. An horizontal prototype will be one that has breadth, but has no depth at all. So that statements mean this is a prototype that will have so many features, but the prototype cannot be able to tell you how these features have been implemented in the system. So if you can be able to do a prototype that will be able to demonstrate to the user the different kind of features you are going to be having on the system, but you find that that prototype doesn't go into depth about how those features shall be implemented, then we do call that one an horizontal prototype. As breadth means that you can be able to see so many features, but it has no depth. That means we are not concentrating on the internal functions of how the system will, our proposed system will be able to implement those functions. Then we look at the vertical prototype. A vertical prototype will be the opposite of an horizontal prototype, meaning that a vertical prototype will has depth, but has no breadth at all. So this is a prototype that will be able to concentrate on a specific function or a subsystem in the product. For example, I can give you an example. I am creating an online shop and I want to be able to come up with a vertical prototype. So maybe I can be able to show the user how maybe you can be able to add an item, or how you can be able to buy an item using my proposed system. So it means that I'll be able to take a certain function in my system and demonstrate to the user how the system I'm proposing will be able to implement that feature into detail. That's why we are talking depth but no breadth. The other one is talking about the features in the system, but doesn't concentrate about any specific function. It doesn't talk about how this feature shall be implemented in your proposed system. So before we move on, Sister Lucy and Charlene, are we at the same page? Charlene and...
Yes, sir.
Yes, sir.
Are we together?
Yes.
Thank you. So we proceed.
Yeah.
Okay, thank you. Just a minute. So we just proceed if there's no question, but if you have a question, I think there's an option for raising the hand. I don't know whether you have seen that feature. There's an option where you can raise up your hand. There's also an option for you to use your microphone. Feel free to interject me when I'm presenting or when we are going through the content together. So we look at the prototype types, and this is something I was alluding to in the introduction. There are different types of prototype, and I want us to look at these different types of prototype so that you can be able to determine at what point do you use a certain prototype. So there's one prototype we call the throwaway, the rapid, or the closed-end prototype. Just like the name suggests, sorry for the pop-up. So just like the name suggests, the developer, in collaboration with the customer, will be able to develop a prototype through the 3 stages. Coming up with the basic requirements, doing the prototype, and refining the prototype using the iteration we have been able to see. But at the end of the day, you'll be able to produce a prototype that shall be acceptable to the end user or to your customer. Once you have this particular prototype that's acceptable to the end user, then instead of building the final system based on that prototype, then you now discard that prototype, or you throw away the prototype, and now you create a system from scratch based on the prototype that the user were able to approve. So this prototype, we are saying, has little effort with minimum requirement analysis to build a prototype. Once the user and the developer have been able to agree on the prototype, then we now discard, or we just throw away, just like the name suggests. So we can now be able to discard, or we can now abandon the prototype, and we start creating our proposed system, since we now have a very much clear understanding of the user requirements. The system we are going to be creating, or the actual system we are going to be creating, will be based on that prototype which the user was able to agree between them and the developer. So that's just one way. Create the prototype, agree with the user, then discard the prototype. Based on that prototype, since you now understand the requirements much better, then we can now be able to start creating our proposed system. There's a reason why I'm calling this system proposed. The reason is obvious. This system has not been approved. Until the system has been approved by the user, that's the system, that's the time we shall start calling that system our final system. But provided that we are still in the process of developing the system, then we always call this system a proposed system. So we look at the evolutionary or the breadboard prototype. So indeed, this is the opposite of the throwaway. Once you have been able to agree on the prototype, then you don't discard the prototype. So you now refine the prototype to become your final system. So you can imagine, for example, you are working on a project, and let's say you wanted to showcase Marist, how they can be able to come up with a school management system. And maybe you just did a very tiny system or a prototype after your diploma course. And maybe it happens that Marist are very much interested in buying this particular system. So now, instead of now throwing away, or instead of now starting again from scratch to do the system, if you are going to be adopting the evolutionary or the breadboard prototyping, then you now pick that particular prototype and enhance it to become the actual system. That's what this type of prototyping usually means. So the well-understood requirements shall be included in the prototype, and the requirements are added and when they are only understood. So it's a matter of the user and the designer first agreeing that we need to have these requirements within the system. Once that has been agreed upon, then you can now keep on fine-tuning the system. But we are not discarding the prototype. We are taking that prototype that has been accepted, then we now make that prototype to become our final system. Then we look at the incremental, or what we call, we have two of them in one slide, We do have the incremental prototype or the extreme prototyping. So we look at the incremental prototyping. So incremental simply means that you are going to be building multiple functional prototypes of the various subsystems. Then we now integrate them to become one complete system. I want to explain this further. Assume you are working on a system for Marist again. Let me just still use Marist. And maybe you did a prototype for how the system at finance could look like. That one becomes a prototype. Then you have maybe another prototype of how the system at registry can work. And you also have another prototype, maybe at library, how that system can be able to work. So you now put these modules together because our assumption is you want to give Marist an enterprise resource planning software or a complete software that will be able to solve issues at finance, issues at registry, and issues at the library department. So those different particular prototypes you have been able to do, then you now bring them together and integrate them together so that they can be able to form a complete system. And that's what we call incremental prototyping. So we are not dealing with one prototype, but we are dealing with small functional prototypes that you can be able to bring together and build one functional complete system. The last type is what we call the extreme prototyping. And this one is usually mostly used for web programming domain. and has 3 main steps. Number 1, it's what we call the basic prototype. This one can just be done using pure HTML. Maybe you can do HTML and CSS to be able to define the structure of your website. So once you have done the basic prototype and you are able to show the user that this is how the user interface will look like using the HTML and CSS, you can now proceed and do the data processing. Definitely at this time, you want to be able, or you want that HTML form, sorry, you assuming, for example, I have an HTML, and within that page, I do have a form which the user is supposed to fill, and maybe the data should be posted on a certain database. It's obvious that you shall require some kind of data processing, and maybe at this time you could be using a language like PHP so that we can be able to do some form of data processing. And the last thing will be on integration of different services and implementation of the final prototype. Maybe you want to integrate a service like M-Pesa within your system. That's the final thing you shall be doing when working with the extreme prototyping. So maybe just a summary for the extreme prototyping. Do the basic prototype using HTML and CSS. Once that has been done, once the static web page has been done, then you can now incorporate some features of data processing. And this one could involve posting some data to the database. After that has been achieved, then we can now do integration of some services, and we now implement our final prototype. Because whichever prototype we are implementing, so whichever prototype we are proposing, that prototype should be able to translate into a final system, unless the user are not very much convinced about the solution we are coming up with. The work of the prototype is supposed to lay a ground so that the user, so that the user can be able to have a ground on how he can be able to, or a ground on how he can be able to do your final system. So those are the 4 main types of prototyping: throwaway, incremental prototyping, extreme prototyping, and the other one we spoke about was, we spoke about the evolutionary or the breadboard, whereby we see the prototype, the final system, as an evolution of the prototype itself. So before we move on to the next aspect, Sister Irene and Charlene, could we be having a question? Anything that might not be clear?
So the last one, the one for incremental, maybe if you can repeat.
Okay, let me just repeat it again. We have said the extreme prototyping is used extensively in web programming domain, or when someone's creating web applications. And we have said this kind of prototyping has like 3 stages. Stage number 1, it's whereby you'll create the basic prototype. And in our basic prototype, we are creating a static page, a page that cannot be able to do any form of data processing. Yes, you can be able to navigate from page A to page B, but there's no form of processing that can be done on that page. That's what we are saying, a basic prototype. And we are saying you can either use HTML in conjunction with the CSS, because that portion will be dealing with purely how the page or how the website or how that particular page will look like on a web browser. Once you have been able to do the basic or the static web page that doesn't have data processing, step number 2 is about the data processing aspect. I could have done a web page, maybe whereby the user is supposed to fill in some data, but it's upon you as the programmer to be able to write a certain code so that once I fill in that data will be stored somewhere, possibly on the database. And that's where you bring in another language like PHP or Python or another language or Java that can be able to take the data in the form and post the data in your database. Some form of processing is now being done in stage number 2. Then stage number 3, you can be able to integrate some other services. Assuming that you are doing an online shop, you might want a case whereby after I buy the items, I'm able to pay using M-Pesa. That means I need to be able to integrate my web application using the M-Pesa service. Or you want me to be able to pay using PayPal. That means you have to integrate that application using PayPal application. And we shall also be implementing our final prototype in step number 3. That means you now take the entire thing. You have done the static web pages, the basic prototype. You have done the data processing. That is, you have been able to do some PHP codes that can post the data in the database. And you have been able to integrate the service. That service could even be a database. So the integration of the service has been done, and we have been able to implement the final prototype. That means at this point, we now have our final proposed system. And now at that point, we now have the system that we wanted to create for the user. Sister Irene, I don't know whether it's much clear before we proceed.
Yeah, it's clear now.
Okay. Charlene, could we have a question?
No, sir, it's okay.
Okay, we just proceed. Okay. So let's see where we can apply prototyping. Number 1, prototyping is very useful. It's very important in development of systems having high level of user interactions. For example, online system. In short, we are saying, if you want to be able to get feedback from the user, before even you start creating the system, then you have to do some form of prototyping. If you are working out or if you are creating a fill-out based application, then prototyping can be used efficiently so that we can be able to give the user the look and feel even before we do the actual software. I keep on giving this example. If I want to automate the process of registration at Marist so that I come up with a system that the users or that the student can be able to use so that they can apply or they can be able to apply for admission online, then I can first do a prototype. I can even do a paper sketch, take it to the management of Marist and show them, if you want to be able to apply, then this is how the form will look like. Even before I start creating the actual software, then it means that the management will be able to know the system that will be, or that I will be able to come up with will look like this. So this one can be able to reduce risk at the end of the software development, because we want to be able to work with the user, and we want a case whereby before we can be able to implement the ending on the system, then it's like we already have a consent from the user that we are okay with this kind of, or we are okay with this kind of feature being implemented in that manner. If you are dealing with a software that involves too much data processing, and most of the functionality is internal with little user interface, does not usually benefit from prototyping. Maybe I can explain this further. Prototyping might not be able to highlight most of the things on the internal, might not be able to highlight very well the internal functionality of the system. If at all you are looking at a case whereby you want to be able to highlight the internal functionality of the system, or there's too much processing being done, then you cannot be able to create a working model that can be able to depict that. And in most cases, you can be able to see the internal functionality of a system once the actual system has been developed. So if you have this kind of a case whereby we just have less user interface and we have a lot of data processing being done, a lot of functionality is being done internally by the system, then prototyping might not be the tool for you to use, because it's not going to bring out those ideas, the fact that we are just working with a working model. And when you are trying to propose a working model, you don't go so much into depth, because again, you don't want to go so much into depth, but you find out that the users are not buying your idea. In case the prototype development could be an extra overhead in such a project and may need a lot of extra effort. This is just an extension of bullet number 3. If you find that the prototype you are trying to come up with might be able to increase the cost of developing the system or might require some extra efforts, then it's upon you to be able to determine, do you still need to do some form of prototyping? Because also in system, you are also trying to do optimization of the resources. These resources could be the people who are working on site. These people could be the resources like the PC and so on and so on. But if you find that the particular prototype I want to come up with can bring some kind of an additional overhead cost, then you need to think careful whether you need to come up with the actual system or you need to do a prototype. In short, what we are saying, if there's a lot of complexity in terms of the development of the system, then prototyping might not be the right technique or might not be applicable at that time. So we quickly look at the pros and the cons of prototyping, then we look at something else. So we look at the pros. Number 1, with the prototype, it's obvious that a user can be able to get a better understanding of that system which the developer wants to, or that the system which the developer wants to create for them. In most case scenario, what I've seen, once you give the user a document, the user will not be able to know exactly what kind of product you are doing. But if you can just be able to do a working model, then they'll have an idea what kind of system it's been developed, and you can even get more feedback from the user from a prototype rather than from a normal document. So we can also be able to reduce time, and cost can also be detected much earlier. In short, prototyping will be able to identify for you the risk areas. You just do a proper prototype, then you'll be able to know exactly what features are needed by the user and what features are not intended or are not needed by the user. So you only concentrate with those features which are needed by the user, and even prototyping can help you to be able to identify risks even before you start creating the system, because risk identification is very important in system. You need to be able to envisage what could be some of the risk of me creating this system, and how can we be able to reduce, how can we be able to mitigate some of these risks. So it's also quick in feedback, since we have feedback being available almost immediately, so leading to better solutions. So you don't want a case whereby you are the developer, you have started from stage number 1 all the way to the last stage, but you find that the user has never given you any form of feedback on your system. Once you leave the feedback towards the tail end of the system development, then your system might be bound to fail. And that's what we are looking at. We want our systems to be successful once we create them. So through proper feedback, then we can be able to do better solutions. If at all we do have some missing functionality, then we can also be able to identify them as we are getting feedback from the user. The problem with most of us as designers, we always want to assume that we are the user and at the same time you are the developer. That should not be the case. You cannot be one and the same person. You cannot be creating the system and at the same time you become the person who shall be using the system. You need to be able to involve the user from the first day to the last stage. In case we do have some form of confusion, then this one can also be identified and rectified even before we start the system. So anything that could be confusing, any function that might not be very clear can be identified and can also be rectified before we even start creating our final system. So let's look at the disadvantages of prototyping. This is something I've seen with most developers and users. You might have some kind of a confusion between the working model and the actual system. And this one can occur in a case whereby you find that you have used an high fidelity prototype. If you are using the same software with the if you are using the same software to develop the prototype, chances of the user being confused between the final system or the actual system and the prototype could be very high. They might not be able to differentiate between which is the prototype, which is the actual system. Prototyping can also increase complexity of the system scope and may expand beyond the original plans. I don't know whether you have ever dealt with the user. Today they tell you, I want this one to be done in the system. Then after you have been able to implement, they tell you again, go back to the previous design. So you keep on going back forth again. And that one can happen if you are doing, or if you are working with a working model. Sometimes the user, they don't know what they want to be represented in the system. And in that case, definitely the complexity of that system scope may even go beyond the original plans. Remember, before you even start creating the system, you need to have a proper contract with the person or with the client. What do you want me, or what do you want me to be able to create for you? What features are you looking at? But sometimes you find through prototyping, you'll find some users will be sneaking in some requirements which maybe you never agreed upon during the first day when you are scoping the project. And this one might even push the system beyond your original plans between you and the user, sorry. So we can also have a case whereby you find a developer trying to reuse existing software to build the actual system, even when it's not technically viable. I want just to explain this using an example. Assuming that I've done an academic management system for QUAM, and maybe it worked very well, then Marist also want an academic management system. I might be forced to use that particular prototype I used in QUAM. But you might find that the way the policies are implemented in QUAM might not be exactly in the way they are implemented in Marist. They might not be the same as they are maybe implemented in Maseno and any other institution. So if I try to use an existing prototype so that I build an actual system, then you find that my system might not be even viable technically. Maybe you might find that Marist don't even have the resources that QUAM have, or QUAM might not have the resources that Marist have, and vice versa. And that one would mean I'm trying to push an existing prototype that might not be able to work technically for that particular organization. You'll find also the other challenge that the effort invested in creating prototypes may be too much if not monitored properly. And that's why you now need to become a team or a team project manager. Proper management of the resources, that is budget, that is time, that is money, you need to be able to monitor that very well, because even the prototype should be factored in your budget. How much money are we spending for the prototype? If you are not very careful, then you might find that you have a contract that you cannot be able to honor, either because you spend so much money or you spend so much time when you are doing the prototyping. So these are some of the issues you'll find in prototyping. The 4 points becomes add-on issues when you are dealing with prototyping. Sister Irene and Charlene, we can just confirm if you are at the same page before we move.
Yes, sir.
Are we at the same page?
Yes.
Okay, thank you. Sorry. So we look at conversions. Yes, you have been able to implement the system. You have been able to do proper coding. And now you want to implement the system, or you want to be able to abandon the old system and come up with the new system. So the process of migrating from the old system, and this old system could be a manual system that was existing, or it could have been a computerized system that you are replacing with the new system. It's what we are calling the system implementation or the system conversion. So when we are implementing the new system, when we are converting from an old system to a new system, as the project leader or as the system analyst, you need to be able to provide an understandable and a very proper structured approach. Or now you can be able to improve communication between the management and the project team. Because if proper system implementation is not done, regardless of how good the system looks like, then the project team and the management, then they'll have some kind of a difference. So we need to have a proper structured approach on how the implementation of the system shall be done. There's something we also call a conversion plan. This is a plan that will be able to contain all the activities that must occur when we are switching or when we are moving from the old system to the new system. And it's going to include what kind of activities, what need to be put into consideration, what need to be put into operation, so that we can be able to implement our proposed system without a challenge. This could be maybe the infrastructure. Maybe you need to have a server room. Maybe you need to have maybe maybe you need to have a network that will be able to connect the user. This is what we contain, or this is what we have in the conversion plan. When you are also implementing the system, you are also supposed to, as the project leader or the project team, need to be able to anticipate or need to be able to foresee what could be some of the possible problems and what could be solutions to deal with them. Because you always need to think ahead. Yes, I'm creating this system, but I'm anticipating that we could be having a problem integrating this system with M-Pesa. We could be maybe having a problem integrating our system with our bank systems. So if that's your concern, or we could be implementing our system, or we could be switching from the old system to the new system, but I don't think that we have enough security policy within the organization. How do you address that problem, and what solutions? Those solutions need to be very well documented on how we can be able to deal with those issues. So let's just look at some of the conversion activities. Then we can quickly look at different methods we can be able to use to convert from the old system to the new system. Then at 9:45, we can do a short break of 10 minutes. So conversion activities will include, number one, naming all the files for conversions. These files could be a certain database that we are using. So that one needs to be very well named in your conversion activity and plan. We also need to identify the data requirements to develop the file during conversion. And this one, or this aspect, could be dealing with the database. So the different data requirements that we need when we are converting the system also need to be very well documented as part of a conversion activity. We also need to list all the documents and the new procedure that shall be required during conversion. If maybe you think there's going to be a need for us to adopt a new procedure, then you need also to be able to document that very well in the conversion activities. We also need to come up with the controls for each activity. I can give you just a typical example. If still I'm creating an academic management system, maybe I need to have a control such that a lecturer, once you key in the mark, maybe you cannot be able to change the mark after the mark has been keyed in. You can maybe also come up with another control that after maybe the lecturer has keyed in the mark, or the lecturer is supposed to be able to key in the mark within a certain locality. Maybe you can even be able to use the IP of your institution so that that system can be used within a certain limit. So these are just some things you need to be able to come up very well when you are dealing with the conversion activities. We also need to identify the responsibility of each user in each activity. And this is very straightforward. If, let's say, you have lecturers within an organization, what can they be able to do within the system? And what will be their role in the system we are proposing? If we have a student, what can they be able to do in the system? If, let's say, we do have the vice chancellor, what can the vice chancellor be able to do within the system? And the many other people who shall be using that particular system. We also need to have the verification of the conversion schedule. For how long do you anticipate that you are going to be converting the old system to the new system? That schedule needs to be drawn up and need to be shared with the user so that you don't find a case whereby you are implementing a system or you are converting a system for such a long time. This needs to be very clear on your side. So we now look at the different plans or different methods you can be able to switch from the old system to the new system. And actually we do have 4 of them. Number one, we can have what we call the parallel conversion. And as the name suggests, we are going to run the old system and the new system at the same time. And once you run the old and the new system at the same time, and maybe you find that the new system is now at a level that will be more acceptable than the old system, you can switch off the old system and now move on fully to the new system. If you find that the old system is doing much better, then it means you don't need to switch to the new system. We also do have what we call the direct cut-over conversion, and this is a very risky way of implementing a system. The direct cut-over, you just switch off the old system and allow the new system to kick in immediately. This one can be a very bad way of implementing systems, because if the new system doesn't perform as expected, then you don't have a fallback plan. And this is something as much as possible, an organization should be able to avoid at all costs. I know at the end of the day, it's going to be saving some cost, because if you are running two systems at the same time, then you are incurring more cost. But once you just switch off the old system and maybe you employ the new system, then you might have a challenge in terms of if the new system doesn't pick. We also do have the pilot conversion. A pilot conversion simply means I can be able to pick a certain section, then I try to implement that system within that particular section. For example, I can maybe say in Marist, I'll pick the smallest department, let's say like IT, implement the system in IT, then let me see how the system fares. If I find that the system is doing very well in the small organization, then I can now start bringing in the other departments. And it's a risky way, or it's a way of trying to cut down on the risk. Because once you have a small organization, a small section using the system, then you find that the system is doing well on that small organization. Then next you can bring another large department or the largest department, then try to see how does the system fare within the largest department or section. If you find that it's faring well in a small and a large organization, then you can now bring all the other departments so that they can now be able to use the system. But as I'm saying, pilot, you are taking a certain section, then you deploy the system within that particular organization. And lastly, we have the phased-in method. And as the name suggests, the phased-in method, it means that you do have a complete system, but this system will not be deployed entirely as one. So maybe you can just, for example, pick the system and say, we shall start with the module, we shall start with the component in finance. Let's see how this component works in finance. If you are okay with the component at finance, we now go in to registry. If you are okay with registry, we go to library and so on and so on. So after some period of time, then it means you are going to be having a fully functional system within your organization. But you are not doing it like one large system. You are just taking module by module, then you are able to implement that module. Then once you're okay, one module is okay, then you bring in the other module. So Sister Irene again and Charlene, are we okay on our side?
Yes, sir.
Yes. So let Irene, sorry, Charlene, now you also okay?
Yes, sir.
Okay. Let me quickly go through this so that we can just have a short break. Then once we come back, we look at another topic. So parallel conversion, and we have just said we are running the old system and the new system simultaneously at the same time. So quickly, if you look at the advantages, it's providing for you a fallback plan. If the new system doesn't work as expected, then just switch back to the old system. Using this method, we can also be able to provide the greatest security, and we can also be able to test our new system ultimately, so that by the time we are switching to the old system, the new system, we are very sure that the new system is much better than the old system. Then we look at the disadvantages of the parallel conversion. Number one, it's about cost. Definitely, if you are running two systems, then the cost will go up in your organization. Then, if the new system might not be able to get a fair trade. When, for example, let's even use the abstract example. When you are trying to compare two people, assuming that you have, let's say you have a VC, we have a current vice chancellor, or let me just use another example. You do have a president, then you now bring another president, and then you want to compare the two. You want to be able to see who could be much better between the two. You might find that the person who has been there will be able to score much better than the person who came in, because first you are judging two people who are not on the same level. And that's why we are saying with parallel conversion, our new system might not get a very fair trial. And maybe we might not be very objective when we are assessing our new system. So we look at the direct cut-over conversion, and it's very obvious. You switch on the old system, and we bring in the new system immediately without even giving the new system and the old system a chance to run in all simultaneously like the others. So when you look at the advantages, first, one advantage which I also even don't think it's an advantage, we shall be able to force the user to make the new system work, because that's the only option you're having. So you might have to force the user that this new system which you have brought, then it has to work with or without a fail. You might also be able to get some immediate benefit from the new system. The other one, where we are having the two systems running concurrently, you might not be able to get the benefit of the new system. You might be getting the benefits coming from the old system. But in this one, entirely, you get immediate benefit coming from the new system. The disadvantages with the direct cut conversion, it's obvious. There's a risk involved with, once you stop the old system and bring in the new system, we don't have a fallback plan. What happens if the current system we are using, or the new system which we have decided will be adopted, doesn't work as expected? That is a major challenge with the direct cut-over conversion. And number two, you also do require very careful planning. You cannot just switch a system off completely overnight, bring in a new system without proper planning. If there's no proper planning, then you will be able to plug your organization into problems with the new system that you want to be able to replace the old system. So we look at option number 3, the pilot approach. And as I said, this is a case whereby the new system we want to be able to implement will be installed in a selected number of users, or this system can be installed in a certain section, for example, accounting section, or let's say registry section, for a small number of people to be able to use that system. Then we will now allow the user to be able to learn, use, and evaluate the system. So these people are just being used like a guinea pig. Try to use the system. Let's get your feedback. And once that has been done, then we can make a decision. Are we going to abort the process of implementing the new system, or do we continue bringing in the other users within the organization? And this is a very common way of implementing systems in most organizations. Pick just a small representative group, let them use the system for a certain period, and we give a report on how the system has been able to fare. So once we now confirm that the new system is performing as expected, then we can now roll out that system to all the other people. That means we are actually now gradually implementing the system across all the users. Some advantages: number one, we can be able to avoid large contingency from the risk management. The fact that we are not installing the system for all the users, definitely, then it means that we have some kind of a risk management on our side. If this system doesn't work for this small group, let's just fall back, or let's stop implementing the system. rather than implementing the system to the old population and the system fail. So we can just continue. So we look at the phased, sorry, we do look at the phased method. This one should be the last one. This is a way whereby we can be able to introduce the new system, but we are also at the same time phasing out the old system progressively. I can give you an example. I do have a system that is supposed maybe to, or it's a system for a bank, but the bank decides that we now need to buy in a new software. So instead of removing the old system, then you are going to be using the new system, or you shall be using the new system. And as you're using the new system, you are also introducing the old system. You are going to be using the old system and the new system, But you'll find that some features of the old system are being progressively being removed and replaced by the new system. And through that, you find at the end of the day, you are able to replace the old system in a very fast manner. So you are taking component, replace this component with a new component. Then after some time, maybe some period, you take another old component, remove it from the system, replace that component with a new component. And that one will keep on happening until that time you now have a complete new system from the old system. So parts of the total system are introduced in a systematic manner across the business. And every time we are bringing in a new component, then we are replacing a component in the old system. And eventually, we are going to have the old system being replaced by the new system, because we are just taking a component in the new system, bring it into our old system, and we keep on doing such until we do have a totally new system, but in a very progressive manner. So the completed modules are released to the customer as they become available. So look at this case whereby I'm the one writing the module, I'm the programmer, I'm the developer. So, and Marist has commissioned me to make for them the system. And they are replacing the old system with the new system. So once I've done a certain module, for example, I've done the module for finance, they take my new module, integrate it in the old system, and replace the old system for finance with the new module. Then that one keeps on happening until we are completely able to replace our old system in our system. So I think this is something you can be able to look at. I just go very quickly. Just some advantages of phased approach. Number one, staffs can be gradually trained, since they all need to train on that part of the system that is being replaced. So you don't need to train the staff entirely. If I bring in a new component, then train them on that new component that we have been able to install on the system. So it's also much easier for you to be able to identify the errors, since we are dealing with one component at a time, as a case whereby we are looking at the entire system at once. In case we have one part of the system failing, then there's that possibility of still going back to the old system, because the old parts of the system are still in use. So if you find that a certain part has not worked as expected, then you have that option of still going back and access that old part of the system, since it's still accessible within our organization. So cons, before we just do a short minute break, I thought we'll do it at 9:45. It's almost 10. We can do 10 minutes break at 10, then we come back. I introduce the other topic, then we can be able to complete on what's remaining next week. So it's more expensive than the direct changeover since you have to test each phase separately. So there's that aspect of more expense being expended on phased approach as a method of substituting the old system with the new system. The fact that we are installing the system in phases, then it can be able to take a long time before we now implement the entire system. So it's not like we are just, or it's not like we are saying this system will be done within a month. This one can take long because we are taking component by component, and one component is replacing the component in the old system. And it's only suitable if you can be able to break down your system into separate components. If you cannot be able to do so, if you cannot be able to break your system into separate parts, then it's very hard for you to implement the phased approach. So this is something I think we have already looked at. And that one marks the end of that chapter. So Sister Irene and Charlene again, could there be any questions that need clarification on system implementation and also prototyping?
No, sir.
Okay, everything is very clear. Okay, so we do 10 minutes break. Let's come exactly at 9:55.